Morning and welcome to our asynchronous day. We've already watched a little video about gas stoichiometry and we've already covered lots of stoichiometry. So this will just be a quick video to introduce you or reintroduce you to the concept, and then you can work through the problems, and if you have any questions, let me know. So just a quick reminder, when we talk about gas stoichiometry, because volume is directly proportional to the number of moles, this means that we can use mole ratios like we use anywhere else in stoichiometry, and we can make them volume ratios because the number of moles is directly proportional to the number of moles is directly proportional to volume. So let's take a look at an example problem, and I think you'll start to see what I mean. So this question says, what volume of hydrogen chloride gas would be required to react with 4.21 liters of ammonia? So since this is a stoichiometry problem, we're going to start where we always do with a stoichiometry problem, and we're going to balance our chemical equation. So we have our ammonia gas, and it's going to react with hydrogen chloride gas. And this is a synthesis reaction, so this is actually going to give us ammonium chloride. Which is actually going to be a solid. And so it asks us what volume of hydrogen chloride gas would be required to react with the 4.21 liters of ammonia. So we're going to start, as we do any stoichiometry, with what we know, 4.21 liters of ammonia. Now, normally in a stoichiometry problem, we would now convert this to moles. And then for moles, we would use the mole ratio and then convert to whatever unit we're being asked. But because this is a gas and we're going to a gas and mole ratios are volume ratios, we can simply say that for every 1 mole of ammonia, there's 1 mole of hydrogen chloride gas. So that means for every 1 liter of ammonia, there's also 1 liter of hydrogen chloride gas. So I'm going to put 1 liter of ammonia on the bottom so that the ammonia cancels out, and 1 liter of hydrogen chloride on the top. And that one's pretty easy math, and we get 4.21 liters of hydrogen chloride gas. Okay, so that one's a really, really easy math problem. Let's take a look at one that might be a little bit more challenging. So this one asks us what volume of oxygen is required to react with 2.82 liters of propane. So again, we're going to start with our balanced chemical equation. We know this is a combustion reaction because we have propane, which is a flammable gas, reacting with oxygen. And so because this is a combustion reaction, we know that our products are going to be carbon dioxide and water. And so I'm going to start by balancing the carbon. I have 3 carbons here, so I'm going to put a 3 in front of carbon dioxide. Oops, I left out my units, my states of matter here. Okay, I have 3 carbon dioxide. I have 8 hydrogens, so I'm going to put a 4 in front of the water. That now gives me 6 oxygens plus 4 oxygens is 10. So I'm going to put a 5 in front of the O2. And now our chemical reaction is balanced. And now we can get to the stoichiometry. So again, begin with what we know, 2.82 liters of carbon dioxide. And it's asking me again for a volume of oxygen. So mole ratios become volume ratios, 1 mole of propane to 5 moles of oxygen, or 1 liter of propane for 5 liters of oxygen. So whoops, I wrote the wrong thing there, sorry. 1 liter of propane, C3H8, is going to give me 5. We're going to require 5 liters of oxygen. And so when we do the math, we get that this is 14.1 liters of oxygen. So again, we can convert from liters to moles using the 22.4 and then moles to moles, but then we'd be converting back to liters with a 22.4. So this just saves us a few steps. Let's do just a couple more. So staying with this same reaction of propane with oxygen, it asks us what volume of carbon dioxide would be produced. And so I'm going to keep that balanced chemical equation there, and it asks me for the volume of carbon dioxide, which is one of my products. So I'm starting with that same 2.82 liters of propane. I'll write that correctly this time. And again, I'm going to use the mole ratios as volume ratios. So that means that 1 liter of propane is going to give me 3 liters of carbon dioxide. And so we wind up with 8.46 liters of carbon dioxide. So again, we're just using the mole ratio as a volume ratio. This only works if we're going from gas to gas. So one last problem, and this is really just a review of stoichiometry, but we're going to go ahead and go through this because it's still with a gas. So we're still working with that same reaction, 2.82 liters of propane reacting with oxygen to form carbon dioxide and water. And it asks us what mass of water vapor would be produced. And so we have 2.82 liters of propane. And now we have a choice. We could convert to liters of water, and then from liters of water to moles of water, and from moles of water to grams of water. Or we could go ahead and convert to moles at this point. And you'll remember from our stoichiometry unit that at standard temperature and pressure, 22.4 liters of a gas are equal to 1 mole of gas. So I've converted from liters to moles. Now I need to go from moles of propane to moles of water vapor. So 1 mole of propane from my balanced chemical equation to 4 moles of water. And every 1 mole of water has a mass of 18.02 grams. And when we do all of the math, that gives me 9.07 grams of water, I think. Okay, so that's gas stoichiometry. As always, if you have any questions, let me know, and I look forward to seeing you in class.